Hello, welcome to this new Open.HD video. In the first part I basically introduced what HD was, I showed you what I'd bought. This time what I'm looking to do is hook everything up, install the software, see if I can get it working, and we'll go from there. So let's jump in.
Okay, so first things first, we'll need to get the software to actually put in our Pis. To do this you just need to get to the Open.HD page, and then if we go to code and the releases at the moment, the latest is RC17, which is release candidate for version 2. This could well stretch. Now I'm on a Pi 4, so I want the Buster one, although really everybody wants to move on to the new one. It looks like they've moved it across. So let's get hold of that. As you see, it downloads an image.gzip file, so we need to unzip that and then write it to our memory card. Obviously you will need at least two, because you'll need a card to run on the Pi in the air and a card to run on the Pi on the ground. Now as far as writing the SD card image goes, you don't simply copy it across to the SD card. You have to use something to actually write the image, and that's because it uses multiple partitions for the Linux file system. And it says here that it recommends using Etcher for writing SD cards. I'm actually going to use something called Apple Pi Baker. I didn't have much luck with Etcher before on my Mac, but I would suggest you follow their one. But let's go over to that now. And this is the write SD card process. It's not very exciting. You select your SD card after putting it in there. Obviously I don't want to accidentally pick one of my external hard drives. I then pick my file and it starts writing. Takes a fair while, about 4 minutes here, so we'll speed this along. And obviously you need to do this multiple times, but there's a single image no matter what sort of Pi you have, so you don't have to worry about if it's going on a Pi 0, a Pi 3, a Pi 4 or whatever. Now I got the official 7-inch touchscreen with my Pi, and one thing I had to do is mount my Pi on the risers, which all came with the screen unit, so that was alright. Basically it's just a case of connecting that ribbon cable and then connecting those 4 servo-like lines to the GPIO pins. It's really worth having a good look at the GPIO pins, because A, the instructions on the screen aren't very clear, but B, you'll need to learn about these anyway. Don't quite know why those lines are so long and the wire's a bit stiff, so I could always replace them with something a bit nicer, but hey, they fulfill the purpose just fine. So I've got the red case for the Pi, so basically I just drop the screen and the Pi that attached to it into this. And then it's just a case of doing up these few screws and tucking those wires out the way as best I can. At which point I can put the top on. And that Pi is ready to rock. So with great excitement and the SD card in, I plugged in the USB Wi-Fi adapter, powered up the Pi, and it started up. Although it seemed like it was upside down. And I started wondering, did I put the screen upside down? No. Did the Pi go in upside down? No, it can only go one way because of the way the case lets you put the USB ports through that. So yeah, that must be a problem. On the plus side though, Open.HD seemed to boot up and we get some sort of OSD there, so off to a good start, just the wrong way up for now. Luckily, and by default, Open.HD on the Pi 4 will actually have a Wi-Fi network that you can get to. So I just checked it out and I was able to connect to it. It's on 192.168.2 here on my system. So I could SSH straight from my Mac onto the system to change a config file that would rotate the LED display. I did encounter a small bug here. I did a sudo su-, which is in Linux terms is basically saying I want to switch to root as a super user. So if configured right, it will allow you to go to root without any passwords in. But there's a little bug here which will be fixed in the next one. Apparently if I use sudo -s it will work properly. Now the reason I was here in the first place was to edit the config.txt file to basically add a little line which would turn my display around. And the little bug we encountered there was after trying to save the file, we found out that the file system was read-only when it should have gone to read-write after I logged in. I was able to work around this manually before I checked back with the Telegram group, which is very active. And that's when one of the devs told me, yeah, that was a small problem he was going to fix up for next time. But we worked around that anyway. Now, if you're freaking out the idea about using Linux commands, bear in mind this is just because I had this certain display. HDMIs were fine, but if you use the SD card, you've got access to the boot partition and you can edit the file on your PC there if you need to. So the next thing to do was reboot the Pi with the display and just make sure it comes up the right way around, which is, hooray, look, I can actually see what it's doing this time. That's good news. Hopefully in future versions this sort of config.txt editing won't be necessary and they can put the whole lot of this sort of thing into the app so you can just select it instead of having to think about config files and stuff like that. But for now it's kind of bare bones and we do what we have to do to get things running.
Okay, so I've booted up my ground station Pi. This is the Pi 4 and what I've done is attached a camera. This bit here is where the camera goes and you can see that's the adapter cable which connects to this 0 Pi. This is a very awkward cable. It's a flat cable instead of having the wires sort of wound together, so it's quite difficult to move around. What I've got here, and the reason I said you need to know about the GPIO pins, is a BEC here. This is plugged into pins 4 and 6, which is 5 volt and ground, and we need to supply a Pi 4 with up to about 3 amps of power. I'm using this SBEC here that can do up to 5, I think it's 5, yeah, so it can do 5 amps and so handle 3 easily. And what I'm going to chuck into the back of that is this huge thing. Ultimately, when you get running, you won't actually be using this in here, and most people actually hard solder it on, so because obviously if that wobbles during flight that can have a problem. So let's plug this in, and as far as the config of this, all I've done is I've plugged in the camera, I've put my SD card in, and that is about it. So I've gone on about it not being plug and play, but as far as this part goes, it actually reasonably is sort of plug and play, sort of by default. So hopefully that's going to start up there. We've just seen we've got the light come on for the adapter has been initiated, and we've got some sort of messages about stuff happening, and yeah, we've got a picture on the screen. There's my hand there, hello. So we got some information. We got the bit rate that's going on there. We've got some information about the ground and the air Pi. But yeah, so that seems to be running. And what I did next, what I'll just do is shut this down. I can use a touchscreen quite usefully to say I want to shut down my air Pi. Don't do that while you're flying, you'll have a bad time. Now here's the Pi 0. Tiny little card this, and very cheap, so it's quite good that you can actually use these with the camera attached. Still awkward even when you don't need an adapter, and I've had to here have this micro USB to regular USB adapters. This is not the config you would fly with. This is very much just my testing on the desktop. I've plugged in again via the GPIOs to have my 5 volt and ground. The Pi 0 doesn't need the whole sort of 3 amps that the Pi 4 does, but it's always best to have a BEC that can handle it rather than one that can't. There is a slower boot up on the Pi 0. It's basically about the speed of the original Pi, but maybe a little bit better, and so it's always sort of maxed out in its CPU terms, and you can see the CPU stuff over there. So we're on like 3% on the ground station because not much is going on. Okay, we've got the network adapters come on, that's good news. We're finding some telemetry stuff coming on. We've got video bitrate there. And there's a picture of some of my room. And the angle of this camera is thus that you have to turn it like this way to get an image, which is a little bit awkward. But you know, there's a radio over there. There's me waving. So yeah, so I haven't really done anything to configure it, but I can just plug this ground station and this in, and they will find a channel and they will talk to one another. So we're off to a good start. Obviously, one thing we should notice on the OSD is, you know, nothing happens. We haven't got any real data here. We've just got stuff about the Pis, about the megabits that are coming across, about the signal strength. All our other stuff is not happening, and that's obviously because we haven't connected anything to a flight controller or anything. And I'm going to do that next, but just before I do, let's talk about the touchscreen functions and what you can do on the screen here, and what you can also do if you don't have a touchscreen. So I wanted to talk about the app, which is called Q Open.HD, and this is the thing that runs on the ground station, and it supports the touchscreen very well. If you touch here, then you've got a load of things. You probably saw me shut down stuff. We got the sort of boot status. We can power down this or the AirPi. We've got the about screen. And within the app here, we've got things like the widgets. Now the widgets are the things shown in the OSD. So this is the OSD, and you see we've got the megabit thing here. So if I went in and said, we don't want to show the bitrate, that would disappear from that screen. And this is how you set the OSD up. Aside from that, you can also just grab things and move them around. And if I just sort of highlight it there, I can change the size. I can change various things about it. Don't like it now because I've just put it off center. Move it up a touch. And different things count for different bits. So we've got the lat long. So it's got an option to always show it even if you haven't got a fix, for example. And so you can see how you can customize things. You can even sort of change the colors of certain things, shape color, text color, and then you've got all the bits you can show and that sort of thing. You can scale the screen up. The picture-in-picture, I'm not sure how that works right now. And then within the radio, you've got stuff like the data rate, the frequency that's used, and in the video it shows you the bitrate percentage, the frames per second, the height, the bit rate, set to auto, which sounds good, the width. So this is 1280 by 720 at the moment, which is 720p. There's all sorts of bits here which I really haven't looked at. This is the hotspot for logging onto this via SSH or something like that. Anyway, it's quite a good system, and so you're not left with this default OSD. You can change stuff about. Now, if you haven't got a touchscreen, you can always connect your Pi to a mouse and HDMI to a monitor and set up the same way, or you can use a companion app on a different device. So I've just turned on that because I wanted to show you what you had on. This is an Android phone. I've just had to crack this out to run it. And this is the Open.HD app, which runs on a phone. And if you don't have a touchscreen, then you can always use your phone to do similar things. I could touch that. I've got all the same old things, so I can change the size. I can drag that about. That sort of thing. Now you will notice that this megabit stays up there and this one moves. This is, well, there is a couple of things actually. There are certain things that should be moving, which is going to be fixed, and there's going to be options so you can have your app set up completely differently than you would on your ground station, because if you've got different resolution screens and stuff, you might want to set that up differently. But there's this one. This is on an Android phone, as I said.
So this is Open.HD running on my Mac, and same stuff. We can change stuff around. We can do gubbins with the ladders and stuff like that. And you can see this is quite a different resolution, and that's where you'd have different sort of settings. But you can get this for Windows or anything else.
Okay, it's going quite well so far. So what I want to talk about now and try out for myself is exactly how I get flight controller information into here so we can see proper stuff on the OSD screen. And this is where the GPIO pins come in again. So what I need to think about now is finding a flight controller, try and hook up to this, see if I can get decent data out of it. Okay, so having read the telemetry section on the Open.HD page, I thought this would be pretty simple. I've got this old Arduino copter copy thing. It's basically like an APM 2 point something, I don't know what, and I thought it's quite good because it's got a power module and I can plug a GPS in, and it's got very accessible pins to do stuff. So what I did, I plugged in the telemetry RX and TX, this little dude here, and this basically goes in pins 8 and 10 on the GPIO, which are coincidentally are the ones next to, if we go from here, it's the top row, so we've got 5 volt again, and ground, which is where I plugged in last time. Then you've got the TX and RX pins, so they're all in a little line there. And I thought, this would be handy, I'll plug this in, it talks Mavlink and we can get the data out. However, what I found is when I plug this in and just put a multimeter on here, the serial logic is 5 volts and the pies want 3.3. So although you can get a little board to reduce the voltage, and I may do that for the future, I needed something right now that would do a logic on 3.3. So just watch out, depending on what you've got, that you're not putting too much into the pie. So what I did instead is break out this guy. This is the HDLRC Zeus F722, and I've flashed it with iNav, and I've stuck the GPS on for fun. And over here we've got TX and RX4, which I've just made into this little server line. It's a bit of a mess, but it's just for testing. So I can take this to the Pi. I've set UART4 in iNav to send Mavlink telemetry. Open.HD seems to like Mavlink a lot. It does understand other types of telemetry, but I thought, hey, it puts out Mavlink, we'll use that. And what I've also done is I've hooked up something to plug into my board so I can get some actual data out there. And you'll notice I haven't taken the ground with me as well. That's because I'm going to use the same battery. So I've come up with this ESC which splits and does all sorts of things. So I'm just going to plug this in and we'll see what happens.
Depending on the board you've got and the type of telemetry you use, you might have to change this setting in Open.HD settings -1.txt. This is the FC telemetry baud rate. It is set by default at 115200, which is what iNav uses. I mention it because my old APM card would use 57600, which I had actually changed it to until I found out the serial logic was wrong. And if you're using something other than Mavlink, there's a couple of things to change there as well, but I felt it was easier to leave it to its defaults to start with. If you do change it, you need to set the baud rate on both the ground and the air Pi.
Okay, we're all plugged in, the board's on, we're just waiting for it to connect there. We've got the camera shooting straight up in the air. The light for the Wi-Fi adapter's just come on, so all good so far. Let's see what happens. Okay, so we got video. If you notice a bit of a camera cut there, it's because I found out I was using the wrong ESC. This one's absolutely identical, but wasn't just supplying the power, it seems, and it was falling over. We've got the right one on now, which looks the same, but it's different. Anyway, so it looks good because if we look down here, we have got 11.1 amps, 11.1 volts rather, and amps it's displaying where I don't want it to, but we don't have an amp meter, so that's a bit weird. And the idea is now that if I pick up the board and turn it like so, we're obviously getting some movement on the screen. And you know, obviously this would be on your model normally, so when this moves, everything else would move with it. So that looks good in terms of getting telemetry over. And obviously if I was outside, I'd probably get a GPS signal here and we'd get, you know, the lat long coordinates. We've also got the flight mode here, which is manual because I haven't set any up. And what I could do now is I could just hook up a receiver to this, plug it all into something and go off and do something. But I want to do the thing where we can not use a receiver and basically pass our RC signals through here. Now what we need to do with this is, instead of having RX and a TX going to the telemetry, so the TX here still connects to the RX here, so we get the telemetry data, but we want to send from the TX to an RX here, so we need to go into a different UART for that, and to do that we need to do a little bit of sorting out on the computer. Doesn't talk S-Bus because S-Bus is an inverted protocol, although I have seen non-inverted S-Bus as well. But we can set ourselves to SUMD or iBus, and then we'll try connecting up from RX1, which I have already got a lead here ready, floating around, and we're going to connect that back, basically remove that lead and put that one instead, and we need to hook up a radio to the back of this via the USB, so for joystick. But yeah, that seems to work. That's just talking Mavlink. So let's go and try and hook the control signal up now. What I'm going to do, as a little check, although I notice you've got like throttle down here, which is quite good, I can hook a little servo up and make sure that moves when I twiddle my sticks around. Let's try that next.
Okay, so to set up the RC controlling, we're back in the good old Open.HD-settings-1.txt file again. We've got this thing called RC and it's set to Mavlink by default. So if you're using a Pix4 or an APM, you want to leave it as this because Mavlink has something where it can pass through. For us using iNav, we've got the choice of iBus or SUMD, so I'm going to change this to iBus. Depending on what you're using as well, you may have to change something called the FC_RC_ baud rate. It's set by default at 115200, which is the recommended use for iNav, but for other things you may have to change it. So you have to do this once again on the AirPi and the GroundPi. So I'm here in iNav, just wanted to show you what I did. As mentioned before, in UART1 I set it to serial RX, that's pretty normal. UART2 has a GPS on it, although that's not by the by for this setup, and UART4 has Mavlink instead of all the other types of telemetry you could have. So what we then did on the receiver tab, we set this to serial and iBus, and this is an F7 board, so I guess it works fine just by telling it it's iBus. It knows that the serial port inversion should be off. If you've got something like an F4 board where you don't have the option to change the serial port around, you might have to choose a little bit more carefully. And at that point, it's all pretty normal. I've got the radio plugged into the ground station, and I can move stuff around and ditto set up your modes as you would normally, and it should just work from there, I guess. Okay, we're firing up and we're ready to plug our control into it. Now, one thing that I found out which is quite important, I've got the end here at the moment because I found that when I had the radio plugged in and it was waiting to answer the question about do you want me to connect as a HID or not, then this would cause basically Linux kernel problems, and the network adapter wasn't found, and that was a real issue. So you could either set it so it always comes up as a HID controller, or you could just leave it until it finds the network adapter and then plug it in, which is what I'm going to do. So as far as this goes, I'm using a sim that I already had set up on this, and one of the things it means is I've made sure of my internal RF and my external RF off. The rest of it though is pretty standard, and in this one I've just got basic 4 channels plus a couple of switches. So let's plug that in and we'll get the normal question. HID for me. Meantime, you'll see we've come up. Hello, here I am. And normal stuff, we've still got our telemetry connected, so that's working okay. Which is forward? That's forward there. So that's forward, left, right. We've got our battery voltage. Lat and long's not going to come on. So the difference is that if now I move the joystick or the throttle control, we should see we've got a throttle control happening here, and that's all good. We've also got just under here, I've connected this servo to one of the channels, so if I now move that, I've got movement, and that's good. And if I change mode using this switch, I think, no, not that one, it goes into hold. It tells me that's RTH on this, but hold, manual, servo moving, and throttle. So yeah, that looks pretty good. Looks like my RC controls coming through okay. Got the telemetry connected up okay. Got the camera connected up okay. So yeah, the basics are working. It looks a right old mess, but this is just for the bench testing. We can tidy this up later, obviously, and that's the next thing to do. Well, there you go. That's what I did for this video, and I think we're off to a good start. I said in the first part, it's not exactly plug and play, but to a certain extent, if you've got the right bits, you just plug them together and they kind of work. Of course, there's many more settings you can dive into and change. I went for sort of the path of least resistance to start with, because you can always fiddle about with those things afterwards. And I've rattled through at a fair old pace, but don't forget, of course, there's lots of wiki pages you should check out on the site itself. There'll be links down below. And I also found the Telegram group, which I mentioned before, very helpful for answering some questions. But of course, don't just join the group and post things like
how's it work help? You should at least be going through and looking and finding the answers, and it's where you haven't got the answers is where you start answering the question. So what I want to do for the next part is, of course, put it on to something. And I wasn't going to go straight for flying. I was going to go for a ground vehicle first. Two reasons for this. First off, if it breaks down somewhere, it doesn't fall out of the sky. Secondly, it seemed like a useful way to be able to do a range test, because ground, if you can go a certain amount on the ground, you can go much further in the air. There are one or two challenges I can think of right now though. The first is these little cameras. Although, you know, they're reasonable, they're not particularly good compared to regular FPV cameras. My main problem is getting them at the right angle and getting them far away enough from the pie. I don't know if there's extension boards I can buy. I'd prefer it if this cable was sort of wrapped in, you know, a nice flexible cable and I could maneuver the cameras around easier, but that's one thing to think of. The other thing is how I get this thing decased, and everybody's saying solder it directly on, but I want to use this in two different pies, so yeah, I can solder it on, but I still want to be able to move it out again. But if I make it with connectors, is that going to make it like the same problem as plug it in a USB? It could come loose. I don't know. Those are things I want to check out. But anyway, I hope to be back for part 3 soon, where we'll actually take it out probably for a drive on a ground vehicle, as I said, and we'll see what we can get from there. Don't forget to like, dislike, subscribe, all that gubbins, and I'll catch you next video. Bye for now.
Well, you've made it to the end of the video, so thanks once again for watching. If you like what you saw, then please consider subscribing, and if you really like what you saw, then be sure to check out the link to my blog for a variety of ways in which you can help support this channel.